the buck converter. So the module which I have previously shown, it is a buck converter. The buck converter in the sense it will step down the DC voltage, DC to DC. So I have given 24 volts input through an adapter that which I have, and have converted into 12 volts, step down into 12 volts DC, and I have given to the GSM module. Okay, so I will show you it again. So this is the buck module that I have shown you. This is the buck module. So now what we'll do, we'll implement the things whatever we have discussed. So we are ready with the hardware and we are ready with the code as well. So we'll just upload the code and we'll communicate with the GPS and GSM modules. Okay, we'll just upload the code again. So if anyone interested, you can also give your number. I will put in code so that you can also experience that whether you are getting the message or not. So if you are anyone interested, you can give me your number. I will put here the code. So first we'll check with this number whether you are getting the data or not. So in the code what I have written, so whenever the serial is available means this serial. Okay, so whenever I call serial, it indicates this serial monitor port. Okay, whenever I call GPS serial, it indicates GPS serial port pin number 2 and 3. And 4 and 5 are the GSM. Okay. So here, whenever I refer to serial data available, means we are checking data whether data is available from the manual interface. Okay. So here I'm reading the data whether using serial dot read command. Okay. This command have given the in the first day of the class I have given Arduino defined functions class. So serial dot read will read the data whatever available in the serial. So if I just send yes here, so yes has been read. Here it is waiting for the GPS signal and it is printing message sent. So why it is sending, it is doing like that means, so whenever I give command as small s character here, so it will do whatever there inside the if condition. So what is there, it will read the GPS data and it will send the message to that particular number which is we have given above. Okay. So we'll check whether I have got the message or not. So I'll just show you through the video that. So I have got the location data here. You can see that. If you want it, I will enter it again. Okay. So this is the hardware here, GSM, GPS, and Arduino. And this is here is my mobile phone, which is getting messages from the SIM card that I have inserted in GSM. Okay, we'll send yes again on the screen. Okay, so yes is the character which I'm using it as a controlling character. So I'm just sending yes. Whenever I send yes, it has to send the message. So we can replace this S with any sensor, any switch, or else if you can put a switch, and whenever you press that switch, it has to send the message. So in emergency cases, you can use it as emergency switch. I will send yes again in the serial. So you on the mobile, on the video screen, you can see whether I'm getting the message or not. So I have just got the message at 14:49 that emergency alert location and some location longitude and latitude details it has given. Okay. So if I click on that link, it will open Google Maps to route the location. Okay. So this is how we'll send alerts through the messages, and you can use this kind of thing to control for any IoT tracking like child tracking. So parents should know the child location. So when parents are sending their childrens to colleges, schools like that. So in that case, you can use this kind of devices. You can put this kind of device in your children's bag or else college bag, and you can have a tracking application, and it will where you can get the location whenever they press any switch, or else you can have any sensors like a vibration sensor or any tilt sensor, any kind of MEMS sensors to detect the any alert situations. Okay, it will automatically detect the alert situations and it will send the location whenever you want. So in this case, we are just using a manual interface, that is getting data from serial monitor. So we can replace that S character with the, any kind of sensors that we have discussed now. Okay, so this is how you can send emergency alerts using GPS module, and this is about sending messages. Okay, so with respect to GSM module, we have seen sending messages. Okay, and with respect to GPS module, we have got longitude and latitude, and in this GSM module, we can make calls as well. So I will show you the calls, how to make calls through GSM module by using AT commands as well. So before going to that part, so if anyone having any doubts or else any queries, you can let me know. Or else, if anyone interested, I will. If you anyone give their number, I will put here so that we can check whether they are getting message of the same message which I have got or not. Anyone is there to check whether the to receive the message, whatever I have put in the code. So I think there is no one is ready to receive the messages through GSM module. Just you are getting the messages from the GSM module. It's not a message that we are sending manually. It's a GSM module that we have done. Okay, so it is the device that we have developed just now. So it is sending messages. So if you just add a keypad, okay, if you just add a keypad to this Arduino module, so you can make calls as well. Like you can enter the number, customize the number. Okay, previously you have entered the number. It said uh, it's given by user in the coding part. So if you want to customize number, you can use a keypad and you can enter the number through the keypad and you can make calls and you can send messages all right through the Arduino device. Okay, so one keyboard is enough to make it a keypad phone. Okay, so by just adding a keypad to this device, you can make a keypad phone that will make calls, send message, receive text messages, and response. Okay, so we'll just move on to making calls through GSM module here. So this is the code on the screen. You can see this is a similar kind of code. This only includes GSM code because I don't need any GPS data here because we are making a call. Okay. So this is about making call. So we'll just enter a number which will make call to that number. So we'll just enter my number here 837457. So here the same thing, we have to define serial port and we have to define the baud rate for the serial port and we have to use AT commands to communicate with the GSM module. And then here, same code, whether GSM serial is available or not. And that's, so to make call, we have to use ATD, AT command, ATD, and then phone number. That's it. Okay. So we'll just upload this code and we'll check whether I'm getting the call or not. So this is my phone here. I will keep it here. So I have just got the call from the number which I have put inserted the SIM card in the GSM module. So this is how you can make calls, but now we cannot answer this call because we don't have connected any. We can answer, but there is no data transfer is there because we have not connected any microphone to the GSM module here. So in case if you connect microphone and speaker at the end of the GSM module side, as we have the same kind of sensors at the phone, so phone also includes microphone and speakers. So in the same way, if you connect speakers and the microphone, you can communicate through that GSM device to make normal calls to communicate. Okay, so this is how you have to make calls and send messages and receive messages. All these things based on the AT commands. All the AT commands is there. I've just used some of the 80 commands which we have seen in the PDF here. Okay. If you want to try all of these 80 commands, you can try. Have given this PDF earlier in the classes as well. So if you just go through that PDF named as basic 80 commands PDF, you can find out these 80 commands there. And for every operation, there is a 80 command, and you can follow through them. So if you get any doubts, you can go to the coding part as well. Okay, I'll just put this code like IoT tracking in the protected text, which we have been sharing the codes through that website. I'll put there. The password is 1234. So anyone have any doubts regarding today's session regarding interfacing GPS and GSM modules with Arduino? So it's a kind of IoT device. So in previous classes, we have seen IoT platforms, IoT cloud platforms. So in this case, we don't need any IoT cloud platforms here because the GSM network acts as a IoT platform here. We don't need any other IoT cloud platform because the SIM provider network will provide you the data for your register number. Okay. So this is a code for IoT tracking. Or also we can put it as a IoT emergency alert. Tracking. So this is how we have to read the GSM and GPS modules data. I put code in the prototype text. If anyone not getting this link server, you can let me know through the class as well. So I will let you know how to go to this link. IoT emergency alert and tracking. So I will put the code for making calls as well. So we have a lot of IoT devices, modules, sensors, and boards are out there in the market. And if you have interest in this IoT platform, you can buy them and you can uh, try them on your own by having some basics from these 5 days classes. Okay, so this 5 days class is like a basic pull, I mean basic push up to the students and who are there interested to learn this IoT platform. So it's just it's a kind of push call. So if you follow this IoT platform classes for 5 days, you can able to start on your own regarding this ESP32, Arduino, GSM, GPS, whatever the things we are following. You can interface on your own after the end of these classes. Okay, as you're getting the recorded video sessions as well, so you can follow through them. So this is about GPS and GSM module. I think we have left some time there. So I'll just interface Bluetooth module as well in today's class. So I think if you have the Bluetooth module with you, you can interface, or else if you don't have, we'll interface in the tomorrow class. But I will guide you in interfacing the Bluetooth module regarding schematic and as well as coding part. I will guide you. And regarding implementation, we'll do in the next class. It will save our time for the next class. So as we have only one day left as tomorrow for the classes. Okay, so I will just it's a similar kind of communication. So regarding Bluetooth module as well, we have to use serial communication, nothing but UART. You can call UART communication as serial communication as well. Remember that. So we'll just open the coding part for Bluetooth module here. So this is a code for Bluetooth notice board where we can display the data whatever you are getting on the notice board of the LCD display. Okay. So here we have to use software serial library as we are using Arduino here. So we'll replace some of the code to customize to our application. We'll change the library name here, and we have to provide the pin numbers. So I'll just provide a pin number uh, 7, 8 as a serial communication port. So the port name is ESP-BT. So I will change this ESP-BT to Bluetooth. Bluetooth serial. Done. So now we have created a Bluetooth serial port for Bluetooth communication, and pin number 7 and 8 we are using for Bluetooth communication. So now we have seen pinout of Arduino, and we have seen whatever the modules we have been interfacing with Arduino. We have seen GPIO first, and then we have proceeded to connect in the circuit diagram. So we'll search for our Bluetooth module pinout, and then we'll begin to interface the module. Okay. So this is the total coding part. So we'll go through line by line. So before going to start this coding part, we'll just see the schematic of Bluetooth module, and we'll just connect. We'll go to the GPIO of Bluetooth module, and we'll try to communicate. So here I'll just open the GPIO for Bluetooth module which we are using. So our Bluetooth module name is H305. C05 is a Bluetooth module name that I am using. I'll search for pinout of that module. So this is the pinout of Bluetooth module that we have to interface. And among these 6 pins, we have to interface 4 pins here, and remaining 2 pins are not needed here. So VCC, ground, and TX, and then RX. So in the same way, you can see same pinouts, only concentrate on these 4 pins. Okay. So leave about these 2 pins. We don't use those pins now. So VCC, ground, TX, and RX. So here also we have to make a serial communication. Okay. So the coding will be simple because we have already done regarding serial communication in case of GPS and GSM modules. So here we have to connect VCC to 5 volts because this Bluetooth module supports 5 volts power source, and ground to ground, and TX to RX, and RX to TX of the Arduino. Okay, so we'll just try to connect the same connections. So first I will remove the I'm going to remove the GPS and GSM module connections. So if anyone have any doubts, I will explain you through the video session because I'm going to remove the connections. Still, anyone having any doubts, let me know, please. So I'm going to remove all the connections regarding GPS and GSM module. So we can just go to the schematics, which I have provided. So now we don't have any connections with the GSM and GPS modules here. We have only one Arduino. Okay, so now we have to connect this Arduino with our Bluetooth module. Okay, so we are not going to implement in the practical session. We are not going to see the output, but we don't have that much of time that will connect the connections, which will offer provide you extra time for the next class. I will just let me take Bluetooth module here now. So this is the Bluetooth module which you have seen on the screen. HC05 Bluetooth module. It will have 6 pins, out of which four pins we have to use for the Bluetooth communication. So I'll just connect this Bluetooth module here. So connect this. Okay. So we have Arduino and we have Bluetooth module. So I'll just give you the schematic and I will give you the coding part. So be ready for the next class. We'll just connect the connections. In the starting 10 minutes, we'll implement the Bluetooth communication because I think some of you don't have any hardware with you. You are not ready with the hardware. So we'll complete this. We'll complete the schematic part and coding part. We'll implement the output. We'll see the output in the next class. Okay. So I'll just let me take some jumpers. So we need four wires. I have taken four wires here. So I'll connect to Bluetooth module one by one. And I'll give 5 volts pin to the 5 volts of the Arduino. So this is the 5 volts pin. I'll connect it to Arduino 5 volts. Here it is. And then ground to the ground. So the module has powered on. You can see the light started to blink in the video. So and then TX and RX pins with respect to the code. So TX should be connected to RX. So I will connect it to 7 because 7 and 8 we have defined on the code. So whatever the digital pins, you can use it for the serial communication code. Okay. So 0 to 13 pins we have, and 2 to 13 pins are pins which are defined, which can be defined as a serial ports. Okay. And analog pins we cannot define as a serial port day because it's an analog port. We cannot communicate through the digital data. So serial communication communicates through binary data, that is zeros and ones, nothing but digital data. Okay, so now I have completed a schematic regarding Bluetooth module. I will show you clearly. So these are the connections. Okay, I think you can see clearly now. So I have connected two power supply pins here, and then I have connected two data pins, serial communication pins here. So this is a small circuit diagram for interfacing the Bluetooth module with Arduino. So now I will just go through the coding part here. So this is the Bluetooth coding part. So I'll comment this unnecessary code here. It is included display code as well. We'll see the display code in next class. Because if I combine both of them, you will get confused. I'll just comment them. So, so we have seen controlling a relay, and we have seen sensing the data. We have seen communication, IoT communication, wireless communications, but we have not seen any local monitoring. So local monitoring is nothing but we have to see the whatever the data measuring through the display. So every time we cannot use serial monitor to check the local debug. So we have to use displays as well. So we'll in the next session we'll integrate LCD display as well, and I will tell you what are the components we have to keep it ready to integrate Bluetooth module with the Arduino. Okay, so to check the data on the display as well. Um, that's it. So now we can check the data on the serial monitor. And regarding that, this is the total code. Here we have 3 lines of code. Here we have 2 lines of code, that is to begin the serials for Bluetooth serial 1. For normal serial monitor is 1. We have to provide the baud rate here, that is 9600. And then This is the condition for checking whether the Bluetooth data is available or not. And then after, we have to read the data, serial data. To read the data, we have to use read string until command. So this command will read the whatever string is there until the line is ending, will read the data. Okay, so this parameter indicates a new line. So whenever the new line is detected, it will read up to that line and it will save it to that buffer in variable. And that buffer in variable, if you want to print it on the serial matter, you can just use this command serial println. This is a string. This is a string that you are getting from the Bluetooth module. Okay, so this Bluetooth module is for communication. Okay, so if you have a Bluetooth application, Bluetooth app, generally we can see some Bluetooth apps, Bluetooth apps for smart watches. Okay, so in that case, you can connect a Bluetooth, your Arduino with your smartphone, and if you want, you can add a RTC module as well. I will show you what is RTC module. So you can make a smartwatch as well. So this is the RTC module which will provide you the real-time data. I mean real-time clock. Okay, so it will provide you the whatever the time is now. If your laptop okay, is able to measure the time every time after the shutdown also means there is a cell inside this RTC module. Okay, so there is a rechargeable cell that will recharge every time whenever the power is on, and it will runs every time if your laptop is shut down also, or else if your mobile is shut down also, the RTC will runs every time and we will get the time. Okay. So in the same way, if you want to add this feature to your embedded board, you can use this RTC module, that is DS3231 module named as DS32T1. You can use it to get the real-time clock. So in that case, what will happen is your hardware will looks like an application that indicates uh, smartwatch. Okay, so you can have interactions between your smartwatch with Bluetooth communication with any kind of app like Bluetooth applications and your smartphone. So this is about total coding part. We have just read the data. We are just printing the data in the serial motor. In case if you want to read that data and print the data in the display, you can just include a library for display and you can just upload the code and you can see the output in the display as well. So for tomorrow class, I'm listing out the components required for the first 10 minutes of session, 10 minutes or 20 minutes, it can be. So you have to get ready with the HC05 Bluetooth module and Arduino Nano or else Arduino Uno, and along with some supporting components like wires, uh, breadboard, along with the display. Okay, display with I2C. So I will show you what is the display with I2C here. 16 cross 2 LCD. So 16 cross 2 here mentions that 16 columns and 2 rows. I2C we have seen I2C communication previously. I have told you that this communication enables inter-integrated circuit. Mediator IC, which will simplify the connections. Okay, so this is the module we have to get. This is the LCD display. This is the I2C module, and you have to get ready with these components for the next class so that you can able to see the data in the Bluetooth, uh, data in the LCD display through the Bluetooth. And as well as I will give you the list of components for the next topic as well. So for tomorrow, not only this topic, we have to complete some more topics as well. So I will give you the components required through the WhatsApp group. I will share you. So there you can get. And that's it. And this is the session for today. I hope you have got knowledge regarding how to interface GPS, GSM, and along with Bluetooth module. And we have seen tracking as well. So I hope you have got total data like schematic, coding part, hardware connection. I have told you each and every step clearly. So still anyone having any doubts, you can let me know. I will clear your queries and doubts.
Participants, please raise your queries if you have anything, particularly in terms of practical sessions or components.
So each and every component why we are showing on the screen means if you can see the component, you can imagine that yes, this is the module. We can also do it, and you will get some confidence for the future applications what you are going to do. So participants, I'm waiting for your response whether you have doubts or not. So I will share you the schematics, and I have already shared the coding part in the protected text. I will share you the schematics through the WhatsApp group, as we cannot share images in that website.
Sir, actually, I have a doubt. Um, while connecting to Wi-Fi, it is not getting connected actually.
So your ESP32 module is not connecting to internet or this Wi-Fi.
Okay.
So you need to yes, you need to take care of Wi-Fi credentials, whatever you are giving. I will tell you three things that you are missing out. You might be missing
Ah,
out. So you have to take care of Wi-Fi credentials, whatever you are putting in your code. So as the Wi-Fi hotspot name and hotspot password, you have to give the as it is. Okay. So with case sensitive. If it is capital letter, you have to give capital letters. If there is no space, you have to check whether there is a space or not, and as well as with the frequency band. Okay, some phones will comes up with 5 gigahertz, and you have to take care of that. You have to enable only 2.4 gigahertz by hotspot. So to that board only, to that network only, our board will connect. And one more thing, these some embedded boards won't connect to the hotspot that is enabled by the iPhone. Okay, iPhones will have some different structure in the hotspot, different frequency in the hotspot. So there is might be a chance you won't connect to your hotspot network. So please prefer Android phone while you're facing embedded boards. So please check with these uh, points and let me know again.
Any other
yes, sir.
participant?
My
Any?
phone is not iPhone, sir, but it is not getting connected actually.
Whatever the parameters I've told you, so please go through them, and after that, let me know after in the next class we can discuss.
Okay, sir. Thank you.
So whatever the points I have told you, capital letters and small letter spaces, all of them, go through them, and after that, please check whether you are connecting or not. We have one more class. In that class also we can clarify. And anyone having any doubts, please let me know still regarding today's class or in previous classes. If you are trying anything in the real time.
Any queries from any other participant?
So if no one having any queries, we can end this session for today. And we have one more good session for the next class, and we will try to learn some more points.
Yes, sir. Thank you, sir. Thank you very much for your session. Participants, if any queries you have regarding yesterday or today's session, you can ping in group also so that we can forward the same thing to the sir. Okay. Thank you very much. Thank you all.
Thank you.